What I might do now is do a little demonstration just to highlight the power of, the actual electrical power being drawn by some of these lights. So these are sort of shorter light fittings. They're 2-foot lights. They're not the sort of 4-foot lights that we typically see in offices, but it's so I can bring them down here in my suitcase. This is just a sort of what we call a bare batten. If you talk about an office, normally this would sort of be enclosed, looks something more like that, an enclosed troffer, with a reflector and a diffuser over the front of it. But just to sort of be a bit more portable, I have this one, but the electrical power is the same. So, if I can you swap that please? That'd be great. If I can get this to work, that's been reversed, that image. Anyway, for some reason, but that one, you can see that's drawing 44 watts. That's a typical light fitting you would see. If it's a 4-foot tube, it's going to be drawing 88 watts of power, okay? Now, the alternative, and they're twin T8 magnetic, twin T8 tubes with a magnetic ballast, okay? This one here, it just takes a little while to warm up. This one here is a single T5 with an electronic ballast. Puts out about the same amount of light. Once you sort of wrap this one around with the sort of inefficient reflectors and diffusers, you'll see that this one here will put out about the same amount of light. But if we look at the power of this one, you can see that. It's actually 16 because it's reversed at 16 watts. So we've gone from 44 to 16, same amount of light. That's the sort of potential we're talking about. We typically talk about a 2/3 reduction in electrical power being used, going from twin T8 magnetic, single T5 electronic. T5 tube is narrow, you might be able to see that. It's narrower, it allows more light to escape. The electronic ballast runs at very high efficiency. The ballast itself does not have a lot of losses within itself, and the light fitting has quite a high light output ratio. There's high performance reflectors in here to reflect all the light out. So we go from 44 to 16, approximately 2/3 reduction. The other one I have is, this is a low voltage halogen downlight. No, it's not. This one is. Okay, so this is a downlight you're all used to. It's a magnetic transformer, big heavy thing. (62 watts). Okay, the lamp itself is using 50. It'll keep going up as the transformer warms up. It'll go to about 63. Excuse me. So 62 watts. It's going to lie to me. 62 watts for the lamp and transformer, magnetic transformer. Now, we go here to an LED, no transformer, same amount of light, or very close to it. Nice LED, a good one, 9.5. So that's a huge saving. We've gone from 63 watts to 9. So we're talking even better than 2/3. So that's the sort of order of magnitude of savings we can get. And that's just changing the lights. That's not control systems and things like that to switch them off, which will give us further savings.